Number 4, consider the following polynomials: 6 times x squared minus 3 and 5x squared plus x plus 11. Two-part question. Find the sum of the polynomials. Find the difference of the polynomials. So if they're asking us for sum, we're going to be doing addition. If they're asking us for the difference, we're going to be subtracting. Let's start with part A. We're going to add together these two polynomials. I'm going to rewrite them. 6 parentheses x squared minus 3 plus 5x squared plus x plus 11. Now, I can't add these two together until I get rid of these parentheses that are protecting the x squared minus 3. The way that I'm going to get rid of the parentheses is I'm going to distribute the 6 to both of the terms on the inside. Now you're multiplying, so 6 times x squared is 6x squared. 6 times negative 3, positive times a negative is a negative. 6 times 3 is 18. So now we can drop the parentheses. I'm going to bring the rest down, plus the 5x squared plus x plus 11. Now we want to combine like terms. So I'm going to start with the largest degree. X squared is the largest degree. I have a 6x squared and a 5x squared. What you do when you're adding x squareds is you're going to be adding together the coefficients only. So the 6 and the 5. 6 plus 5, if you need the number line, use the number line. 6 plus 5 is 11. So 11x squared. So covered those two. Next, I want to go to the next highest degree, which is just a regular x value. So now I'm going to grab the regular x. I don't see any other regular x's. It's just that. So I'm going to have it as plus x. And lastly, now that I'm done with that, I have the whole numbers. Negative 18, 11. Now again, this is where you want to have that number line. Okay? I want you to do a quick little number line sketch if you need to. You're at negative 18 and you're going to add 11. So you're going to go 11 to the right. Negative 18 plus 11 is still going to keep you in the negatives, and you're going to end up at negative 7. So now we've done the negative 18, we've done the 11. We're done. We've added together the two polynomials. Part B. Now we have to take the difference, which is a little bit trickier. So again, I'm going to rewrite 6 times x squared minus 3. The difference means I'm going to subtract 5x squared plus x plus 11. Now, the first step is still the same, but this is the tricky part here. The way that I wrote it by putting the minus sign is not going to get me the correct answer. Since I'm subtracting the entire polynomial here, what I have to do is I have to protect it in the same way that I protected the x squared minus 3. I have to put parentheses around the second polynomial because I'm subtracting the entire thing from the 6x squared minus 3. So you're going to have two sets of parentheses here. First step, just like we did in the last one, we have to distribute the 6 because we want to get rid of the parentheses. So if we distribute, we're going to get the same thing we got before. 6x squared, 6 times negative 3 is minus 18. And now we have another set of parentheses. To get rid of those, we have to distribute this negative. Now that negative isn't just a negative, there is that little invisible 1 in front of the parentheses. So we're going to multiply every term. We're going to distribute the negative to every term, which will end up changing the sign at each one of these terms. So negative 1 times 5x squared is negative 5x squared. Negative 1 times a positive x, you're going to get a negative x. Negative 1 times a positive 11 is a negative 11. And now, we're going to start combining like terms. So again, start with the largest degree. We have our 6x squared and our negative 5x squared. We're going to subtract 6 minus 5, which leaves us with 1. 1x squared. Done. Moving on. We have the negative x, which is our only regular x term. So I'm just going to bring that down, negative x. And lastly, now that I'm done with that one, I have the whole numbers. Negative 18, negative 11. So again, this is a time where you may want to pull out the number line. I'm at negative 18, and now I'm going to be subtracting 11. So I'm going to be going to the left. I'm going to count 11 boxes to the left. I'm going to end up at negative 29, which is why I told you from the beginning, you want to have a very long number line drawn on your paper if you still have issues with adding and subtracting negative numbers. So we're going to have at the end here, negative 18 minus 11 is negative 29. We're almost done. The only thing is, I don't need the 1 in front of the x squared. I showed you that because I wanted to make sure you understood we did 6 minus 5, but we don't keep that in our final answer. Our final answer, we drop the 1 in front of the x squared. X squared minus x minus 29. That's our final answer. Let's move on to number 5. Graph y minus 1 equals 3, parentheses x plus 2. Now, if you're going to be graphing something and you notice that the y and the x are both raised to the 1 power, what you're looking at is a linear equation. It's just going to be a regular line. What you need to do is you need to put your equation into slope-intercept form. It's the easiest way to graph a line. Now, slope-intercept form looks like this. Y equals mx plus b. M is your slope, which if you express it as rise over run, it's really easy to graph. And then the number at the end, the b, is your y-intercept. It tells us which point we can put on the y-axis to start from and then count the slope. So let's rewrite the y minus 1 equals 3, parentheses x plus 2, and let's put it into y equals form. Now, I'm going to start by getting rid of the parentheses. I'm going to distribute, just like we did in the last question, the 3 to the x term and to the 2. So we're going to get 3x, and 3 times 2 is plus 6. Bring down the y minus 1. Next, my goal is to get y by itself. So I'm going to get rid of that negative 1 by adding 1 to both sides. The negative 1 and the plus 1 cancel. So now we bring down the y. 3x, 6 plus 1 is 7. Now, we have it isolated for y. Now we're looking at this and we're trying to pick up what's my slope and what's my y-intercept. My slope is 3. It's the number, the coefficient in front of the x. And I want to express the 3 as a fraction so that I can count rise over run. 3, since it's a regular whole number, I can throw it over 1, and now I have rise over run. 7 is going to be my starting point. That's my b value, 7. So I'm going to go to my y-axis. I'm going to plot my starting point, the 7. And now I count. Now my 3 over 1, since it's positive, means I'm going to use positive movements. So I'm going to go up 3, right 1. Rise up 3, run to the right 1. Starting back at my graph, I'm going to count up 3. 1, 2, 3. To the right 1. Plot a point. Now I can't really keep going because I have no more graph left. So what I'm going to do is I'm going to change the direction that I move. So instead of going up 1 and right 1, I can flip it and go the complete opposite direction. I can go down 3, left 1, and it will still be part of my line. So starting back at 7, down 3, 1, 2, 3, left 1, down 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 1, 2, 3, left 1, and then I'm going to go off the graph. Connect it with a nice straight line. Do the best that you can. If you have your student ID with you, you can use that. And here's our line. And you're done. Number 6. Give one solution to 2x squared plus 5x plus 2. Now we can't come up with a solution unless we have an equation. So step 1 is you're going to set this equal to 0. Always do that. If you have an expression, you have to set it equal to 0. Now, notice this is a quadratic, so we're going to do the same thing that we did in the first problem and use that AC method. So step 1 in that AC method is we're going to multiply 2 times the 2. And we get 4. So we're going to rewrite x squared plus 5x plus 4 is going to equal 0. Ignore the equal 0 for now. We're going to go through the same process we did before in terms of creating our little bubbles. So now we're going to come up with factors of 4 that add to equal 5. So I'm going to set up my little chart so I can organize my work. I'm going to start with 1. 1 times 4 will give me 4. 1 plus 4 equals 5. That's exactly what I wanted. Perfect. First one that we did. So now let's start creating our bubbles. We're going to have x and x, and we're going to put plus 1 in one bubble, plus 4 in the other. Now we need to bring back the 2. So we're going to bring back the 2 by dividing both of these factors by the 2. So I'm going to put 1 over 2 and 4 over 2. Now let's simplify these fractions if we can. 1 over 2, well, that's as simple as it goes. You can't simplify that any further. 4 divided by 2, well, 4 divided by 2 is 2. 2 goes into 4 twice, so I'm going to simplify that to be 2. And now I'm going to bring back the rest. Bring down the bubble, x plus, close the parentheses, next one, parentheses, bring down the x plus, bring down the equals 0. And now I can't keep that fraction there, so we're going to take the 2, we're going to bring it in front of the x. So we're going to have 2x plus 1 and x plus 2, because the second one didn't have a fraction anymore, equal to 0. Now this is the new step that we didn't do for the first one because they didn't ask us to come up with a solution. For this one, you only have to give one solution, but we're going to work out both. What you do is you're going to set each of these bubbles equal to 0. So I like to call it teeing it out. Create a little T. Each one of these expressions is going to be set equal to 0. So 2x plus 1 equals 0, and x plus 2 equals 0. Now, let's solve the one on the right first. To get x by itself, we're going to subtract 2. That cancels. And now we have x equals 0 minus 2 is negative 2. That right there would give us our one solution and we'd be done. But let's do the other one as well. So 2x plus 1, I want to get the x by itself, so I'm going to subtract 1 from both sides. Now we have 2x brought down equals negative 1. And now I'm going to get rid of the 2 by dividing 2 on both sides. So that cancels. So now I have x equals negative 1/2. So your one solution could be negative 2 or it could be negative 1/2. And I'm going to write down x equals negative 2 or x equals negative 1/2, whatever you'd want to give them as an answer. And you're done. Just remember, the only thing different about this problem is that they're asking you to actually solve it, not just factor, but solve as well. So you have to set each bubble equal to 0. Number 7, solve each of the proportions. Now you'll notice a proportion is when you take two fractions and you set them equal to each other. The way that you solve is you cross multiply. So for example, if I had A over B equals C over D, the way that I would solve is I would multiply the things in the diagonal. So I'd multiply A times D, and on the other side, I'd multiply C times B. I'd put the equal sign and do C times B. Now, you'll notice that in a lot of these examples, you're going to have a binomial or maybe even a trinomial in either part of the fraction. Now, to protect those, you're going to have to make sure that if you have a binomial, for example, if D was a binomial, you'd protect it by putting it in parentheses. Let's take a look at some examples. So, starting with the first one, I'm going to multiply x minus 3 times the diagonal 4. So now, 4, I'm going to put in the front because it's just a single number. And then I'm going to keep the x minus 3 in parentheses. Equals the other diagonal, 5 times the x. 5 times x is just 5x. Now, to continue solving, you're going to have to start distributing to get rid of the parentheses. So 4 times the x and 4 times the negative 3. So 4x, 4 times negative 3 is negative 12 equals 5x. Now, you want to isolate your variable. You want to get x's all to one side. I recommend always getting the x's to where there's a larger x value already. Between 4x and 5x, 5x is the larger x value. So I recommend subtracting the 4x to get it over to the right. So I'm going to subtract 4x from the left, subtract 4x from the right. These cancel. Bring down the negative 12 equals 5x minus 4x is 1x. You don't have to write the 1, so it's just negative 12 equals x. Now, most of you probably don't feel comfortable having the x on the right, and you want to rewrite this to be x equals negative 12, which is completely fine. Next question. 9 times p plus 5 is our first diagonal. I'm going to keep the 9 on the outside, protect the binomial p plus 5 by putting it in parentheses, equals. Now my other diagonal, 10 times p minus 3. Again, 10 on the outside, protect the binomial p minus 3, and now we distribute. So we're going to multiply 9 times the p and 9 times 5. 9 times p is 9p. 9 times 5, 45. Equals 10 times p, 10p. 10 times negative 3. One's positive, one's negative, so it's going to become negative 30. And now we have p terms on both sides. So again, I recommend getting all of the variables to the side where there's a larger variable already. So between 9p and 10p, 10p is the larger variable. So what I want to do is I want to get the 9p to the right. So I'm going to subtract 9p from the left. I'm going to subtract 9p from the right. This way, on the left, the 9p's cancel. Now we bring down the 45 equals 10p minus 9p is 1p. But as we remember, we don't have to write the 1. So I'm going to just write p. Bring down the negative 30. Now, my goal is to get p by itself, so now I'll look at the whole number. To get rid of the negative 30, I'm going to add 30 to both sides. The negative 30 and the positive 30 cancel. 45 plus 30, if you're not sure how to do that, 5 plus 0 is 5. 4 plus 3 is 7. So 75 equals, you bring down the p. And you're done. You can rewrite p equals 75. Now that we've done 2 of these, you should pause the video, try the last one by yourself. Well, hopefully now you're back after trying it by yourselves, and let's do it together. Start off with the first diagonal, 3 times n minus 10 equals 9 times n plus 3. Now, 3 need to distribute to both terms, so I'm going to get 3n. 3 times negative 10 is negative 30. Equals 9 distributed to both, 9n. 9 times 3 is 27. Again, look for your larger variable term. In this case, it's the 9n. So you want to start with the variable terms, and now I'm going to bring the 3n over to the right by subtracting 3n. Bring down the negative 30 equals 9n minus 3n. 9 minus 3 is 6n. Bring down the plus 27. Now, I'm going to get 6n by itself, so I'm going to subtract 27 from both sides. Again, this is where the number line would come in handy. But negative 30 minus 27, you're going to get negative 57 equals 6n. Now we're not done yet because n is not by itself. So we need to get rid of the 6. The way that we're going to do it is we're going to break up this multiplication by dividing both sides by 6. Now, 57 does not go into 6 evenly. Okay, so what we're going to have to do is we're going to have to do some long division. Let's try it out. 57 divided by 6. Now 6 doesn't go into 5, but the largest value that can go into 57 is going to be 54. 6 times 9 will give you 54. So we're going to subtract 54 from 57. 7 minus 4 is 3. 5 minus 5 is 0. Now, we're going to have a remainder of 3 because 6 can't go into 3. So our remainder is 3 over 6. Now, what does that look like? That looks like 9 and 3 over 6 is equal to n. We can simplify that a little bit further because 3 and 6 both have a greatest common factor of 3. So if I divide the top by 3 and the bottom by 3, I can simplify this fraction and I'll get 9. 3 divided by 3 is 1. 6 divided by 3 is 2. So 9 and 1/2 equals n. That is my final answer. Leaving it as negative, it's a negative. Negative 9 and 1/2. Leaving it as negative 57 over 6 is an improper fraction. If that's an option as a multiple choice, It's correct. But if they needed you to simplify a little bit further, it would be negative 9 1/2, which is also equal to negative 9.5. 1/2 is equal to 0.5. Okay, you're done. Solve for x in terms of the other variables. Okay, so what they're asking us is they're asking us to isolate the x, to get the x by itself. You have to look at your inverse operations and make sure you're doing everything you need to get x by itself. Let's take a look at the first one. Now, when you have something being added or subtracted, you want to get rid of that first. Look at your equation. You have your x being multiplied by 6, then you have plus d, and then you have an equal sign that breaks it up with k on the other side. So really, you're only worried about the 6 and the plus d. You want to get rid of that plus d first. Whatever is being added or subtracted, get rid of that first. So we're going to start by subtracting d from both sides. That's going to cancel. Bring down the 6x equals k minus d. And now we want to get the x by itself, so we do know it's being multiplied to 6. So we're going to divide both sides by 6. So now we have x equals k minus d all over 6. And you could leave it just like that. Final answer. Next question. Trying to get the x by itself. The x is right here. So it's being multiplied to 3 or to negative 3. You're going to deal with that all the way at the end. You have j being added. You have negative 2m being added. Let's start with the negative 2m. It is being added or subtracted, so that's one of the things where we start with first is whatever is being added or subtracted. But the reason why I start with the negative 2m instead of the j is because I'm noticing there's an m on the other side. So let me get the m to where there's an m on the right. So I'm going to start by subtracting adding 2m to both sides to get that to cancel. Now, we have j minus 3x equals m plus 2m. Remember, there's an invisible 1 in front of the m. So 1 plus 2 is 3m. Next, I'm going to take the j, which is being added to the negative 3x, and I'm going to get rid of it by subtracting j. So subtract j from both sides. Bring down the negative 3x equals. You can't combine a 3m and a j because they're not like terms. Two different variables. All you can do is put them next to each other. So we're going to have 3m minus j. Last step is you're going to get rid of the negative 3 that's multiplied to the x. So we're going to divide every term by negative 3. The negative 3's cancel. So now you have x equals 3 divided by negative 3 gives us a negative because it's a positive and a negative. 3 divided by 3 is 1. But we don't need to write the 1. So we're just going to have m. And then negative j divided by negative 3. Well, the two negatives are going to form a positive. So you're going to get a positive here. However, there is an invisible 1 in front of the j. So you can either express this as just j over 3, or you can write it as 1/3 j over 3. 1/3, or just 1/3 j. Okay? And that will be a final answer. Okay. Last one. Pause the video, try it for yourself, and then come back. Okay, last one. I'm going to try to get x by itself. So what we're going to do is we're going to get rid of the negative b first because it's being added or subtracted. So you're going to add b to both sides. We're left with 5x equals 2L and B, well, they can't be added, so just put them next to each other. 2L plus B. And then the last step is we have to get rid of the 5. So we're going to divide everything by 5. Every term by 5. 5s will cancel. So you're going to have x equals 2 divided by 5 is 2/5, 2 over 5L, plus, you can either write it just like this, B over 5, or you can write it the way we did before, 1 over 3, but in this case, 1 over 5, 1/5 B. An equivalent answer here would be x equals 2L plus B all over 5. That's if I just did a straight line across at this step and just divided the entire right side by 5. So these two, these are the same. They're equivalent. So they may give you an answer or a multiple choice selection, and they may give it to you as this option, or they may give it to you as the second blue option. Both are the same. Both are correct. And we're done with 8. Number 9. We're going to graph two functions. Both of these functions, you'll notice, are very similar. They have an exponent that's a variable term. This is called an exponential function. So write this down. Exponential function, which means you have an exponent that's a variable. Now, most of your exponential functions are going to follow the parent function. The parent function is the basic exponential function that we have to learn about. Now, I want you to think about the parent function as y equals lowercase b for base to the x term. If your b value, your base, is larger than 1, if b is greater than 1, your parent function is going to look like this. And that's a quick sketch. However, if your base is less than 1, maybe it's 0.5, 0.75, your exponential function is going to be going down. However, both of these parent functions, regardless of the base, will cross the y-axis at the same point. They're going to cross at the point 0, 1 for both of them. And we can see why when we create a little table of values. So these are your parent functions whenever you see that there's going to be an exponent term. Sometimes you'll see something being added or subtracted to the end of that exponential function, and that just tells you if you should move your graph up or down. If it's a positive addition, you move it up. If it's a negative addition, you're going to move it down. Now, let's take a look at our two examples. We have y equals 3 to the x power. Now, what I want to do is I want to create a little table of values for you to create your sketch. Here's what we're going to do. We're going to create a two-sided table where you'll have your independent variables for x on the left, and you'll have the function 3 to the x power on the right. Now, what does that mean? That means I'm going to put an x value of 0, a 1, and a 2, just to get a couple of good points for our graph, and we're going to see what we get. So if x is 0, you're going to plug in 3 to the 0 power. One thing you should know, this is very, very important. Any number raised to the 0 power gives you the same value, and that's 1. It could say 3 to the 0, 10 to the 0, 0.7 to the 0. When you raise something to the 0 power, you get 1. So this is our first point, 0, 1. Now the next one, if I plug in 1 for the x value, 3 to the first power is just 3. And lastly, if I plug in 2 to the x, 3 to the second power is 3 times 3, which is 9. So we have 0, 1 as our first point, which I told you in the beginning is always going to be our y-intercept. The next point we're going to have is 1, 3. And then the last one we're going to have is 2, 9. Let's plot those points and create a rough sketch. 0, 1, 1, 3, 2, 9. And just like our parent function, with a base larger than 1, like we wrote our notes for, we're going to create a nice smooth curve. And there we go. There's our graph. You want to make sure you do not let the left side of this dip below the x-axis, unless, of course, there's something being added or subtracted here. Right? But for the most part, if you just see 3 or 2 or whatever base to the x power, do not let your curve dip below the x-axis. Let's try the second one. We have y equals 2 to the x. Now, I'm going to do the same thing I did before. I'm going to create a table of values. So, I'm going to have x and 2 to the x. Just adjust this a little bit. There we go. Okay, x and 2 to the x. I'm going to use 0, 1, and 2. 2 to the 0 power, always going to be 1. So my first point is at 0, 1. 1, if I plug it in for the x, is 2 to the first power, which is 2. So 1, 2 is my next point. And then the third one, 2. Plug in 2 for your x. 2 squared is 2 times 2, so it's 4. So 2, 4 is my last point. And I'm using these just to create a rough sketch. Putting my first y-intercept of 0, 1. Then I'm going to have 1, 2. And then the last one, 2, 4. I could probably continue going if I wanted to here. In fact, I'm going to throw in one more point just for fun. So 3 and 2 to the third power. So this is going to be equal to 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So it's going to be 8. Last point is 3, 8. So let me plot that last point. 3 all the way up to 8, which is here. And now I'm going to create a smooth curve, and when I go to the left, I cannot dip below the x-axis. And we're done with that question. Now I want you to put a note at the bottom that's very important. Okay. For your exponential functions, 0, 1 is always the y-intercept. So I want you to write down 0, 1 is always the y-intercept in basic y equals b to the x exponential functions. Make sure you have that note down. Okay, let's move on.